Hey folks, Quill18 here, and welcome to another episode of Let's Build a Base Building Game in Unity. In between episodes here, what I've done is I've gone through and created all the XML files for the missing objects and updated the wall and whatnot, such that when we load this map, all of our graphics look once again the way they're supposed to. We can put down an oxygen generator and it looks right. We can put down a mining drone and it looks right. We can put down a stockpile and it looks right, or will be as soon as that gets constructed over here. And also, I fixed an outstanding bug with the doors. The doors, we still have this horrible thing in the furniture sprite controller for the doors to orientate them either vertically or horizontally and deal with their animation over here. Not that one. What am I thinking of? Right over here. Yeah. Terrible code. So when a piece of furniture gets created, if it's called a door, then we check to see, like normally a door is oriented so that it's a line that goes left to right, basically. So in other words, that would be an example that you walk through from north to south or south to north. But what we're doing here is we're checking to see if the tile to the north of the door and to the south of the door are both walls. If so, we rotate our door graphic so the door is properly oriented. But we've got that all hard-coded, and for a while it was set to if object type is equal to wall, but then we renamed the walls to like fern steel wall or something like that. So I just changed it to be contains wall instead, which fixes that. But again, this is all horrible hard coding over here, not to mention the horrible hard coding for the animation. So that's still outstanding. We've got to fix it at that point. That's not what we're doing today. But I did want to say that that's still something we're going to look at. So yeah, so now we can load this map, and all the graphics seem perfectly fine, and they're all loaded from that XML over there, which is great, because again, when you build out this project and put it, when you send it to people, they can tweak the graphics, they can tweak the XML files to insert their own graphic sets, which is really exciting. So what we are going to do today, we are going to resolve a outstanding, well, sort of bug, but I don't know, cheat or something that we put in, which is basically when we go and construct something, if I go and build a basic wall over here, which needs steel, our character, as part of his job to build this wall, asks the inventory system to tell us, or to tell him, the character, what the closest source of steel is. And the system lies to him. It's a function called GetClosestInventoryOfType, but the system lies to him and just returns the first thing in the array, which is very fast to return, but may not be optimal for pathfinding. In fact, definitely is not. So we have long left that sitting. We are going to go and fix that today. So to review, over here in character, this is our do job code over here, and one of our do jobs is to find... Hang on, where is it? Closest, right over here. Walk towards a tile containing the required goods. So we ask here the inventory manager to get closest inventory of the type we need. So this is the type that we need. This is our current tile. This is how much of it we need. And are we allowed to take from a stockpile? Because if our job is to fill a stockpile, then we've got it currently set that you don't take stuff from a stockpile to a stockpile. Obviously, we want to change that later with like a stockpile priority system or something of that nature. But for now, that's going to be good enough for us. So we ask, again, this inventory manager, get closest inventory of type. And if we go to that over here, it lies. All we do is return the first one. I've also got this note about, not really be able to do it in the most optimal manner until our inventory's database is more sophisticated. Separate tile inventory from character inventory. It maybe has room content optimization. This is not entirely true. Because first of all, character inventory is not... to the best of my knowledge, doesn't get tracked. When a character picks something up, that inventory gets removed from our inventory's database. Because we don't have an entry in this dictionary here of inventories. We don't have an entry to represent the inventory that is being hauled by a character. So if if a character picks up 5 steel from a stack of 50, well, again, we don't create a new stack of inventory to represent the 5 that he's carrying. We just have the old stack, which only has 45 left. Or if a character empties the old stack that was on the ground, that old stack gets deleted completely. But again, that character itself doesn't have his inventory tracked in here, or shouldn't, unless, we've got some sort of bug in the process, which is certainly possible. So part of that isn't quite accurate. I still think that there's room for the actual optimization of the pathfinding itself. When we do room content optimization, basically we track what inventory is in each room and then first do a pathfinding pass on sort of the room graph itself, which would be a very simple and minimalistic graph. But for now, we are going to go ahead and simply update this to do pathfinding. So when we want to find the closest object of a type, so here we make sure that we actually have it in the database. And then over here, what we do is we just loop through this inventories database, until we find something of type. Okay, so it actually is, or no, we know the type. So what we do is we do technically start this loop because we're just looking for the first valid one, the first valid item of this type in here, which depends on if we can take it from a stockpile and whatnot. Inventory tile furniture. Why is that? Oh, because this would be a type of furniture. So if we're allowed to take it from the stockpile, then that's great. We can just return the inventory. If we can't take it from a stockpile, then we have to make sure, we have to check to see if there's a stockpile here, which stockpile technically counts as furniture. So if the furniture is null, then obviously there's no stockpile. If it's not null, then we have to check to see if it's stockpile, and then we can return that inventory. Great. Well, great-ish. So this, again, just returns the very first valid inventory item we found in our array. So what we have to do is we have to pathfind. Now, I thought of a couple of different ways to do it. One thing, and I've talked about this before, is you can build an entire Dijkstra map of your entire world based on your inventory. And basically what it means at that point, when you've got this map constructed, is at any time you want, you can just say, hey, from this tile, where is the closest steel plate? And you just know instantly. It's pre-calculated for any single tile that you stand on, whether you're asking for the top left corner of the map or the center of the map or whatever. You build this map. You build the Dijkstra map. It parses every single tile, processes every single tile in your map, finds every bit of that inventory, and then updates an entire graph of the entire map so that at any given time you know exactly how to get to that your closest inventory item without fail. The problem is, our maps are relatively big. They're like, 10,000 tiles? No, they're more than that. Maybe they're 10,000 tiles. I guess our map is currently set to 100 by 100. And any time any piece of inventory would change, anytime a stack of steel plates get picked up or dropped, we have to recreate this entire Dijkstra map. And I feel, and we'd have to keep a different Dijkstra map for every single type of object. And I'm guessing, and smarter people are going to have to go and do all the benchmarks. I suspect that won't be quite as efficient as just doing a pathfinding go at the time that we need it. So rather than pre-calculating stuff, instead, from our character outwards, just go tile by tile until we hit the very first steel plate, and then we return that. We'll have to compare different scenarios, and there's different ways to optimize both things. Another possibility is, rather than a Dijkstra map, I think you could do a D-star light sort of map of the world, and in which case updating a D-star light, and you need a separate D-star light map for each type of inventory, but updating a D-star light map is much, much lighter weight. So whether you're dropping in a steel plate or picking up a stack of it, it should be a much lighter weight operation to update that map. And that might be the best way to do it going forward. But in any case, we're not going to worry about that for now. We are actually just going to piggyback on our A-star class. Now, technically, what makes A-star A-star is you need to know what the end tile is, because it uses the knowledge of where the end tile. So with A-star, you're starting from one tile, you're ending somewhere else. And with A-star, you're using this end tile as a hint, part of a heuristic in here to, there we go, heuristic cost estimate, to guess if we're actually progressing in the right direction or not. And A-star uses this as a hint so that it doesn't actually have to scan out in every direction. It scans towards the object until, say, it hits a wall or a dead end, at which point it sort of like backs up and tries again. Other than that, it's basically the same thing as Dijkstra's algorithm. Dijkstra's map is basically a full map version of every single tile, but Dijkstra's algorithm is basically, we start from a start tile, we work our way outwards until we find the end tile, and then we know the path to the end tile. We can stop. As soon as we hit the end tile, we can just stop at that point. Well, here, the tricky part is we don't know what our end tile is. Well, we could. Here's what we could do. With our inventory manager, we can loop through each piece of valid inventory. So instead of returning the first one, what we could do at this point, we could do an A-star pathfinding to this item and save the path plus total length of travel. And then over here, we could return the path with the shortest total length of travel. The problem with doing this is if we have like 100 stacks of steel plates scattered throughout the map, then we're gonna have to run the A-star algorithm 100 times. And that's obviously terrible. So what we're gonna do instead is we're gonna use basically Dijkstra's algorithm, and instead of having a target tile, we are going to simply have it go out in every direction, and the second it hits any steel plate, the first one it hits is going to be the closest one to us, at which point we can just stop and return there. Now, rather than write a second pathfinding pass, and again, A-star is basically Dijkstra's with this heuristic optimization so that it can minimize what direction it goes into. We can piggyback on this. We can say something like inventory object type. Actually, it doesn't have to be inventory. It can just be the string of object type. That's going to be okay. Because what we can do is something like this. For end node over here. So basically, we can do something like if tile end is null, then we are simply scanning for the nearest object type. We can do this by ignoring the heuristic component of A-star, which basically just turns this into an over-engineered Dijkstra's, it's hard to spell, algorithm. Basically is what this is. I might be lying to you in about 30 different ways, but let's pretend and give it a try and see what happens. So we're now going to allow tile end to be null. If it is, then object type can't be null. So over here with the goal, what we're going to do is we're going to have goal set to be equal to null to start off with. And then we're going to say if tile end not equals null, then we set goal to be equal to this. Right? If tile end is null, then we are simply looking for an inventory object. So just set goal to null. So like that. So we assume it's set to null. We check to see if tile end is not null, in which case we set the goal to that. Then we just get started through this algorithm. You know, it will find. So we don't actually use tile end directly, right? If you look here, actually, if you just run the search, you can see we don't use tile end directly. What we use is goal, and what we can do is find a reference to where goal gets used. And it gets used here for the heuristic cost estimate, and it gets used to check to see if we've reached our goal. And that's it. Yeah, so heuristic cost estimate gets used over here as well. So what we can do here is in our heuristic cost estimate, we can say if b is equal to null, we have no fixed destination, i.e. Probably looking for an inventory item. So just return 0 for the cost estimate, i.e. all directions are just as good. Right, so this is normally the hint that we use to figure out what direction we should be traveling in. But we will just simply return a 0. Technically it's a float. It would auto-convert it, but let's do something like that. So the distance is the same no matter where we're going. The only thing our algorithm is now going to care about is the length of distance traveled, since it can't use a guess. So that covers this bit, and then what we have to do is just cover the goal. Right? If current is equal to goal, then we have reached our goal. Well, what we can do is put in the thing. So first of all, if goal not equals null and our current is equal to our goal, then we've reached it. Alternatively, we can check to see if it's got if this tile has the inventory that we want. So current dot dot data, which is a tile, dot furniture. If the furniture is actually no. Dot inventory. If the inventory is not equal to null, and current dot data dot inventory dot object type is equal to the object type that we're looking for, then that's our goal. So those are our two possibilities. If goal is not null, then we're just checking to make sure that hold on, because then we don't want to check this second part. So if goal is not equal to null and our current tile is equal to our goal, then that's good. Otherwise, we have to make sure that goal is equal to null. If goal is equal to null, and then our tile has inventory and the inventory type matches, then we've reached our goal. And either way, it's fine, because then we would just reconstruct the path from where we came from. And that should work. I can imagine a million different ways that we have just broken things, but I think this is going to work. Again, we don't need to use this effectively. We don't need to. We've got an A-star algorithm that we're sort of breaking into not being A-star when we're looking for an object type. And we could do it a different way, but this minimizes how much code we have to write. And we've already debugged this, so we know it's working okay. Probably at some point we'll find a better way to do this. There's no probably. We will at some point do that. So now instead of doing this, first we, so we don't need to do this for each loop, right? Because this for each loop was we loop through each one and do a pathfinding for each one, which would be terrible. So instead, so this is the version that just returns the absolute closest thing, which we don't want. Instead, what we want to do is this. We want to say, hey, path A star. What do? We create a new one, right? Because it needs to exist for this. Yeah, and we construct it. So path A star path is equal to new path A star. It needs an instance of the world, which, how do we find this? World.current. There we go, world.current. Then we need a starting tile, which is where our character is standing, which is T. So we've got that. Then for tile end, we say null. We don't know, we don't have a destination tile in mind. Instead, we have an object type in mind, like that. Now note, right now we're going to be ignoring the can take from stockpile, which I guess we're going to have to pass, as well as desired amount. Yeah, I guess we do need that information. So we'll throw that in there. Oh, these can be, we can call this without that, obviously. Set this to null, equal to 0, equal to 0. These are optional because the alternative might be a tile end version of it. Oh, this is a Boolean, so have a default to false. So we'll want to put in some of this information. So we have to make sure over here that our tile has enough stuff. I think I'm going to want to make this a little bit neater rather than have a giant if, because we actually have to check some more things. So instead, I'm going to have if goal not equals to null, then and else. Looking for inventory. If goal is not equal to null, then if current is equal to goal, then we do the reconstruct path and return. Otherwise, we're looking for inventory. So now we're going to want to check to make sure that the type is correct. Type is correct. But we also need to make sure if can take from stockpile is true, or again the current.data.furniture is equal to false. So either we can take from a, or null, either we can take from a stockpile, or there's no stockpile, or current.data. What's the other thing we check? Or, yeah, or there's no furniture at all, or the furniture stockpile is equal to false. So either we're allowed to take from a stockpile, or there's no furniture here in the first place, or there is furniture, but it's not a stockpile. So that's okay. So stockpile status is fine. And again, we could do this as one big if thing rather than these nested ones, but I think this adds just a little bit more clarity, and it's not really any slower. So our final if is there enough stuff? Well, I guess we don't actually care about that, do we? That's a good question. Do we care if there's enough stuff? So imagine, so to build a wall, we need, what, like 5 steel plates. So if the closest stack of steel plates only has 3, and there's one further away that has 10, do we just ignore the one that has 3 and run to the one that has 10? I mean, at some point, that you'll run into a situation where none of your stacks, like if you've got all your stacks of steel plates are less than 5, then you can never build something, even though technically we have enough. I think what we'll do is we're just going to ignore the desired amount. Yeah, I think that's what we're going to do. We're going to ignore the desired amount and just return the closest stack that's got any amount of the right type. That way it also keeps the map a little cleaner. And I think that's going to be, I think visually and everything, that's going to make a lot of sense to the player. So then we can go ahead and reconstruct the path and just return at that point. So there we go. So now we have a path which is to the closest object of that type rather than anything else. So we've got this path, get closest inventory of type. And what we do, what we're looking to return is return the inventory pile. We could actually save the character some time and return the pre-constructed path. That wouldn't be a bad idea. Because what's going to happen in the character when he says, get closest inventory of type, it returns just the inventory stack, which we don't even save. We return the inventory stack, and then we set the inventory stack's tile as our destination, which will later be pathfounded. But we can return this. What I think what we need is 2 variants for inventory manager. For get closest inventory of type, what we want is another variant here that it returns a path A star. And again, at some point we'll probably want a superclass to path A star, just called like path or something like that. But for now, this is going to be fine. So this is going to have the same signature over here, but it's going to be get path to. And I mean, maybe we won't end up needing the other one, but one can imagine that we might still need both, one that returns the inventory stack and one that returns a path. And really the path version is the master one here. So I'm going to get rid of this fix me. I'm going to take this, cut it out here, bring it there. Hell, we can get rid of all these comments and make things a lot neater. Like that. Like that. And all we do is we return the path. Like this. Right? And for closest inventory of type, what we do is we call, because it still has to do the pathfinding, so we call this with object type T desired amount and can take from stockpile. And we store the path. Path A star. Path is equal to this. What we'll return here is we return path dot. We want the last tile. Because it gets a Q. Can we get the final tile from the queue? So it's like public tile end tile. So if path is equal to null, or path.length. Yeah, we don't track any of that on a queue. Return null. Return path dot. Because this is path is a queue. Peek at the top. I guess what we can do is convert it to an array and then grab the last one. That's probably... Well, I can try path.last. I guess that's probably what we're going to do. Okay. Is equal to 0. Do that. Otherwise, return last. So this is going to return the end tile, the destination tile. Because normally we know that. Because normally when we ask path A star to make us a path to a tile, well, clearly we know the end tile. But in this case, we don't. So this will get us an end tile. So an inventory manager here, dot inventory. There we are. So this version returns the actual inventory that, you know, that is the closest. I don't even know if we're going to care about this, but technically it is possible. So in our character, right now, assuming there's no bugs, which I'm sure there are, but we'll run it in a moment. Right now, this should work exactly like things used to, except it'll correctly return the closest one. Let's actually give this a test. We're going to optimize this little sequence in a bit here. But yeah, because we're still asking for just the closest inventory of the type, which it's going to store there, and we set that as a destination. Let's see what happens when we run that. First of all, compile, no syntax errors. Okay. Hit play. Load. So we're going to try to construct a wall over here, and if we've done it right, it should grab from this 4. Okay. Argument cannot be null. So where does that happen here? We can't just double click to see it. It's at path A star line 30. Path A star line 30. Oh, we do pay attention to tile end at some point over here. Let's just move this, because that is definitely an error. Let's move that inside of here. Make sure tile end's not null first, and then we're going to go and check to make sure that it's in list of all tiles. And that's going to be okay. All right. So luckily, that's an easy bug to solve. It's the ones that, like, doesn't give you an error, but things don't work right. Those are the bad ones. So again, let's try building a wall over here. Okay. Oh, yeah! He's not going to grab from the 4 stack. He's going to grab from the one that was closest to him. But now if we do this, it should be the 4 stack. And it is. Jesus Christ, it's working. And then he's going to grab one more from the closest, which is the 3. And then do that. Excellent! It is working. Now, there's an optimization. Because obviously, we find... over here, this function, GetClosestInventoryOfType, does a pathfinding to find the closest inventory item, but then just returns the inventory itself, which we set as a destination tile. And then our next cycle of our character then does an A star function to find the closest path to this tile. We can save ourselves a step, because we can say get path to closest inventory of type, which doesn't return inventory supplier. Instead, it returns a path A star. Which actually we can just set as our path, because our character has path A star. If we just set our path A star to that, and our destination tile, just to say, path A star dot end tile, like that, then we are all hunky-dory. We want to check to make sure that this path A star is not equal to null, or that path A star dot length is greater than 0. Well, what if we're already standing on the tile? No, we already checked that. We already checked to see if we're standing on a tile that's got the right inventory. So, at this point, we need to make sure path A star isn't null, which actually should never happen. But let's check anyway. And that it's got a length that is greater than 0, so that it's walking us somewhere. And then we fail out. So now, we should save ourselves one whole A star call. But we should still have things working the way they were. Let's find out. Load. Cycle over. Build basic wall here and here. Nope. Now we're getting errors. Okay, let's find out here. Maybe I gotta get rid of all the load sprite commands, actually, because it's a pain to get in there. No tile contains objects of type steel plate to satisfy job requirements. Okay, so why is that? Clearly the path A star's length is returning... Oh my god. Is equal to 0. We don't want to check to see if the length is greater than 0. Greater than 0 is good. That's what we're looking for. So let's try that again. And load. And pen. And do that. And okay. We are properly getting some errors again. Yeah, I'm going to get rid of these load sprite debug log commands because they are very spammy, and we're good. I guess we'll keep those XML commands. So let me try this again, just to make sure that's cleaned up while I'm thinking about it. And load, and basic walls, and ooh, you actually scooched up by one and then stopped. That was interesting. Next tile is cur tile, which is how we end. So it looks like he actually does scooch up a little bit. There's something that's slightly off with the path, the pathing. If I tell you, because this doesn't need material, let me go and build an oxygen generator over here, and then build a wall over here. All right, just take one step. Why is that? Debug.log. Path A star returned with length of plus path A star dot length. Feels like it's not coming out with enough stuff, or the path is somehow broken or weird. So again, I'm gonna build something random over there. And then, so we should get a path of like 1, 2, 3, 4, because I can't remember. We can't go diagonally through there, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. And it does return a path with 9. And then path with 8, and so on and so forth. Oh, I think it's returning... The first tile in the sequence might be the tile we're standing on, which might not be what we expect. Or, hold on, is it possible that the order of this is a little inverted, that the end tile is actually the first tile? That's possible with our stack. The order of that array might be a little bit inverted from what we expect. I'm just going to try that and see what that does for us. Nope. All right. So at some point it's saying the next tile is the current tile. Is it that the first one is already done? And has one length too much? I think it does. You know what? Because what we're doing is we're setting the path. Let's take a look at what happens when we want our movement to happen. Let's ignore the first tile, because that's the tile we're currently in. So we do a little one of those as soon as we get our object. Ignore first tile, because that's what we're already in. That might be the same sort of issue we had to work around before. Because that's what it's feeling like. It's getting the next tile in the queue, and it's like, well, this is already where I am. What the hell? Load. I mean, we could change a little something about the structure, the way we work through our code. There we go. Oh! You looking for that every single frame? Oh, that's interesting. All right, so we're working, which is awesome. But, so what we do is we check to see, like, at this point, okay, we first check to see if the job has all the material. It's not. We get here. Then we check to see if the tile we're standing on has material. And it doesn't, so we have to walk towards the tile. And this is where we do the search for the closest item. Well, that means that every single frame we're rechecking this, which probably isn't what we want to do. Any chance we already have a path that leads to the items we want? So if path A star is not equal to null, and path A star dot endtile dot inventory is not equal to null, and path a star dot endtile dot inventory dot object type is equal to desired object type. We are already moving towards a tile that contains what we want. Oh, we need desired. Boop. Now, I'm rechecking this every frame because it's possible that someone else has gone and ninja'd our resources. So it's possible we already had a valid path that was supposed to lead us to some sort of inventory type thing, but that inventory type thing went away. Someone else picked it up or it got blown up or something like that, so it's gone. So at which point, we are already moving towards a tile that contains what we want. So, do nothing? Probably, yeah. Else, we need to find our way there. So now we're going to grab all this and do that. One way or the other, we are now on route to an object of the right type. So we can now return. So it's a good thing, actually, I left that debug command in there, because I wouldn't have realized that we were doing the path A star every time. Now, we wouldn't have noticed before, because it was quite fast, because we were just grabbing the first thing in the queue. But now, we should be. There we go. Only does it once. Calls function is enterable. Whoop. And then we get an error. But we're most of the way there. As you can see here, I'm going to get rid of this calling function. This is letting us know we're calling some Lua functions. Let me kill that debug. And then that brings me over here. So you can see here, returns path of length 9, which is good. I wonder what this error was. Why would we get an error on this line here? How could that ever happen? Object reference not set to an instance of the object. Is it happening inside? Hang on, that doesn't seem to make sense. Load. Build wall. I mean, this error is fine, but that first error... What? It looks like the error is actually happening at line 195, which is where I am. But how can this say it's not set to an instance of an object when this one works fine? That doesn't make any sense. Maybe it's getting confused because of something else? Right, here we just quietly return null. And length we just quietly return 0. So the only thing we don't just quietly return some value is with the actual DQ. But wouldn't this return over here? If this operation was invalid, wouldn't right over here we would have gotten a 0. Debug.log, actually, if path is equal to null, debug.log, attempting to DQ from a null path. Actually, there should be a log error. And then we'll return a null for a null tile, because we have to return something, so we may as well do that. That's weird. I mean, this is not what's breaking our program. But that there shouldn't be an error right there. Nope. Yeah, it's returning with a length of 2, and then throwing an error here of a type that doesn't really make sense. hell? I might have to put a cut in here. Now, anyway, let's deal with the next bug here. 172. It's complaining object reference not sent to an instance of the object. Probably endtile is returning null. Which can, yes, certainly happen. Of course it can happen. This is totally legit. Dot endtile not equals null. Because we can have a path star, but it might not have a valid path. So I should probably do a temporary, because this is a lot of calls to endtile. Endtile is equal to that. Hang on. All right, let's just get rid of this. We'll optimize it later. So make sure the endtile is not null. But there's still something very bizarre going on here. They're still throwing an extra error that doesn't make any sense. This one is kind of legit. So you're working, which is great. I'm very happy that you're working. Why on earth are you working? Oh, so is it just me or is path A star return? Like, are we running this more often than we should? And I think the answer is very yes. Yeah, you're definitely running that more often than I would expect. So it's still not catching some case where we're already happy. It might be because it seems to happen when we have a distance of length 2. And when we've got a path of length 2, the first tile is the tile we're standing in, and the second tile is the destination. So at that point, we have some sort of queue that's being processed too early, which actually makes sense. Right, because what's happening is our path is empty, right? Our end tile is empty. We have no path left, but we haven't actually entered the destination tile. So, if we're already moving, we don't have to do anything. So we can just say something like, if cur tile not equals next tile, we are still moving somewhere. So just bail out. So we have some sort of move already in. We might have an empty path, but we don't want to search for it until we're done our existing move, because there's a good chance that this final move will end us on a tile with some goods. So that still doesn't get rid of the one error that I'm really super confused about. Build basic wall. But there we go. We are no longer spamming that pathfinding anymore. That wall gets built. There we go. All right, very correct. This is going to be driving me nuts. I'm probably going to throw this one to the comments. What? How on earth is this? Object reference not sent to an instance of the object. But it is, though. If a star is equal to null, then debug dot log error what? Single question mark. And then in our dequeue command, we check to see if path is null, and it's not. If path dot length or count is less than or equal to 0, log error what with 3 question marks? Like, none of these should be possible. And even if it were, wouldn't our error message be somewhere else? It might be getting confused because it's the single line function call. That's probably what's going on. I'm betting there's some sort of internal optimization where it's turning this into some sort of inline function, and that's why we're not getting our information in the right line. I bet you that's what's going on. There we go. So we're getting a single what? So we're getting over here. So, wait. Wait. How is pathstar not null here? Load. Play. No, really. What? So, this error is triggering, but this one is not. So, ntile is somehow making path A star into a null? All this is doing is returning something that we're stuffing into destile. At no point should path A star stop being anything. Debug.log, path is null or empty. How on earth is path A star going from being a valid object to an invalid object? Load. Build wall. This, what? This function is resulting in path star suddenly becoming a null object. Okay, there's clearly, it's going to be one of those cases where I'm doing something really dumb and obvious, and I can't do it because I'm trying to record. I mean, at most, we could be manipulating stuff within the object. So path A star is an object. It's got a path object inside it, which is the queue. Conceivably, we could be breaking the queue in some way over here by some weird, bizarre way, but at no point should the instance become deallocated, or is there like a separate thread or something weird that's going in here, and between here and here, the path A star, which is a variable that belongs to our character, changes. I don't know. I'll figure it out between episodes or something. This has gone on long enough. Thank you very much for watching. We have gone and optimized our inventory pickup, which is something we've been needing to do for a long, long, long time. Also, if you download the current build, then all the sprites for all the furniture works properly, which is excellent. Really excited about this. This error isn't stopping us from working. It just doesn't make any sense at all. It's path star returns with a length of 2. And I mean, where is it doing it there? It's when we're standing there. So let me go a little further away. And run that there. Yeah, it always gets the what on the first go. But it's there, not here. Because we instantiate it here. Well, that's not true. Is it weirdly possible path A star is null? It's possible that we actually got, like, it's been null the whole way, but we just haven't been resolving it correctly. We have no path to object of type, desired object type. Return. Is it possible that it's been A star, it's been null that high up? build the oxygen generator over there. Build you over here. Nope. It's definitely not. This is the only point at which path A star is equal to null. And I mean, that's what I assume because of this. I mean, we should return after each one of these, in a sense. What the hell happens here? God damn it, this is going to keep me up at night. All right, thanks for watching, folks. I'll see you next time. Bye-bye. Hey, thank you to all the June patrons who support these videos through July and early August, and especially these Mike Check supporters. We've got Steven Stagger again, and Michael McClintock again, and Kale the Quick again. Lots of agains. Drazion, Adjective, Jason Yanity, Wes Olenbeving, Craig Mortel, Neil Blakey Milner, Speedy Savant, Valiant Cake Fiend, Aaron Toyvson, Marius Fieldvold, Jan Torre Vel, Ole Peter Talgo, Julien Auger Lafont, Petrie Michaela, and absolutely everyone who has watched, shared, favorited, and subscribed. Thanks for continuing to make this a reality, and I'll see you next time.